This is problem 22, chapter 17 of Giancoli 6th edition. So what we have here is 2-point charges. One is 3 microcoulombs and the other one is -2 microcoulombs, and they are placed 5 centimeters apart on the x-axis. At what points along the x-axis is the electric field 0, is the potential 0? Okay, so let's do the following. We are going to assume that the negative charge, let me put here, the negative charge, I'll call it Q1. This negative charge, which is -2 microcoulomb, let me assume that it's exactly at x0. So I'll call this point here x0. Okay. And then 5 centimeters apart, somewhere here, I have the other charge, the positive charge, which is +3 microcoulombs. So this is, so since we are 5 centimeters apart, this x here is 0.0 meters. All right. We want to know at what points in this x-axis is the electric field 0. This is the first question. So how are we going to do that? Well, we already discussed in class, there is no point outside this line where the electric field could be 0. Let's just do some examples to convince ourselves. Now, so if I pick a point here, the electric field from charge 1 is towards charge 1, then this is the negative one. From charge 2, it is away, and you see there is always these angles involved. We'll never be able to cancel these electric fields. Okay, so we know that the only way to cancel this electric field is to look for a point in this line that connects the two charges. I know for sure that it cannot be anywhere in between the two charges. Why? Well, remember the negative electric field is towards it. Now, so this would be the E1. From E2 is the one away from it. So both have the same direction. So we can never cancel it, right? So any point connecting the two charges will not have a negative electric field. So we discard this possibility. So we know for sure that we have to be outside, never in between. We are either here or here, along that line. So how are we going to choose that? If I choose, remember, if I don't think much and I try to put it here, what would happen? Remember, E1, the electric field is towards the charge Q1, the negative charge, and the electric field is away from the positive charge Q2. Okay, so they both have opposite directions, so things look good here, but the problem is that the electric field from Q2, since we are closer to Q2, will be very large, much bigger than the electric field from Q1. And so, because the charge Q1 is far away, and the charge Q1 is very small, smaller than Q2, so there is no way that they would cancel at this point. So the only way, and this will always be the case when we are dealing with electric field, the only way where the electric fields can cancel is along the axis, along the line that connects the two charges, never in between them, no? Always closer to the smallest charge. So that's the way. No? So it will be somewhere here, because here we have E1 towards the negative charge, and we have E2 away from the positive charge. The positive charge, the magnitude of it is larger than for the negative charge. Now Q2 is larger than Q1 in magnitude, so we'll then be able to cancel the two here. All right, so this is the point, and now let's try to find this point. So I know for sure it's not in between the two. I know, no, so here, no, no, so let me put here, no, and it's not closer to, not, and beyond this point, it's not here either. It's not closer to the larger charge. It's always closer to the smaller charge. Okay, so now let's put the equations together to try to find what is this x. Now, so in WebAssign, we are going to enter a negative value for this x because it's below this point here, which we are calling 0. Okay, but how are we going to find the magnitude of this x, of this distance from the charge q1? So what we have here will be k. I'm writing now. Well, let's write what we need. We want the electric field from particle 1 to be equal to the electric field from particle 2. So what is the electric field from particle 1? Remember, in this equation, we are just going to get the magnitude of the electric field. Now, so I'm going to put k, the absolute value of q1, and the distance from q1 to this point here that where the electric field will be 0. So I'm going to write this distance that I don't know. I'll just call it x squared. Okay? And this has to be equal to k q2. And what should I put now for the distance? Well, I have this whole distance here, this 0.05, plus the x that I don't know. So I have this whole thing here. So I'm going to write the x that I don't know plus 0.05 squared. And this is the equation that we need to solve. Now remember, a very good hint is, instead of trying to solve a quadratic equation, square root both sides and things will become much easier. Before doing the square root, first thing, remember that this k cancel. Okay, now I do the square root of both sides, and the equation that I have to deal with is the square root of that q1, just the magnitude of that q1, divided by x, and on the other side, the square root of q2, the magnitude of q2, divided by x plus 0.5. This is the equation that we need to solve to find the x. And so it's much easier than solving a quadratic equation. Important thing to remember, in WebAssign, when you enter this number, you have to put a negative value, again, because we are before the origin, below the point 0. All right, so this is part A of the problem. Part A was to find the electric field, the point where the electric field is 0. And remember, the electric field is a vector, so we have to find the point where these two vectors cancel. So these two vectors have to have the same magnitude and opposite direction. Very well, now let's go for part B of this problem. Part B of this problem is not about electric field anymore. Part B of the problem is where is the potential 0. Okay, so now we want to know where is the potential 0. Remember, the potential is just a scalar. It's not a vector. So all that we need is that the potential from charge 1 and the potential from charge 2 cancel. Okay, so remember our line here, I had the Q1 at this point 0. The Q1 was the negative charge. I had the Q2 at this point 0.05, 0.05 meters. And this was the positive charge. And now I want to know at which point the potential, these two numbers, one number associated with Q1, another number associated with Q2, will be 0. Remember, what is the equation for the potential? The equation for the potential is K Q over R. This Q, yes, we care about the sign. So the sign here matters. So remember, we can get potentials. They are either positive or negative. It will be negative for negative charge. It will be positive for positive charge. This charge here is negative. This charge here is positive. Okay, So where could the potentials cancel? Well, motivated by what we already did for the electric field, I could try, for example, a point somewhere here. Can I find a point somewhere there where the potentials will cancel? Yes. So at this point there, what would I have? What would I need? The potential from 1 plus the potential from charge 2 being 0. And what is the potential from charge 1? K, Q1, which is negative, divided by this distance here that I don't know, and I'm calling it x. Okay, so this is a negative number. All right, this is a negative number because I'm going to put the sign of Q1. And what is the Q2? The potential from Q2 is K Q2 divided by that x that I don't know plus that whole distance here, this whole distance here, which is 0.05 meters. Okay, so this is what I need. I need this to be equal to 0. And so one number is negative because the sign of Q1 is minus. The other number is positive, so yes, I will be able to find an x where these two things cancel. Okay, but is this the only point where they can cancel? Let's think again. And again, we are not playing with vectors now. We are playing with scalars. How about a point somewhere here? Could we get 0 potential here? Well, again, let's look at the potentials that we have. We have the potential from charge 1 is negative. The potential from charge 2 is positive. So there must be a point also in between the two charges where they can cancel. Closer, of course, to the smaller charge. So there are 2 points when we are dealing with potential. There are 2 points where the sum of the potentials can cancel. One, always these 2 points are closer to the smallest charge, but one before the charge along this line and the other between the two charges. Okay, so there are 2 points where the potential can cancel. How are we going to find this other point? Well, again, V1 plus V2 have to be 0. Let me now enter the numbers that we have. So we have, for V1, we have K, we have minus 210 to minus 6 coulomb, and we have this distance that I'm going to call here another x, another unknown. Okay, so here I'm going to put x. And on the other, for the other potential, I have plus K. What is the charge? Plus 3, 10 to minus 6. And what should I enter as the distance from charge Q2? That whole d, that whole distance minus x. So now here I'll put d minus x. So you see that this is different from what we had here. Here was d plus x and here is d minus x. Okay, and now it's just a matter of solving this equation and you're going to find this x. Remember, get rid of the k, and this is just a constant, and that's the problem to solve. So let's just repeat, summarizing this whole problem again. When you're looking for the point where the electric field is 0, electric field is a vector, so the point will have to be in this line that connects the two charges and closer to the smallest charge, and there is just one point beyond, not in between the two charges, but before this small charge, so somewhere here. When we study potential, potential is a scalar. Potential is positive for positive charge, and it's negative for negative charge. So the point where the sum of potentials can be 0 is again along the line, but there are now 2 points. There is a point before the smallest charge, and there is another point also close to that smaller charge, but between the two charges Q1 and Q2.